Welcome to Brain Vision.
This is Chapter 2, Problem 4. So in this problem, we're given a starting and ending position for a ball, and we're also given a starting and ending time, and we're looking for an average velocity. Well, we know average velocity, so that's going to be, you can write it as v bar is equal to our change in position, or in other words, our displacement, divided by our change in time, or the time interval that's elapsed. So if we find the change in distance and the change in time, we can find our average velocity. And we're able to find both those values. So using the starting and ending positions, we can get our change in position by subtracting our initial position from our final position. Since our ball started at a positive position and went to a negative position, we expect that our change in position is going to be negative, and indeed it is. You subtract those two and you get minus 7.6 centimeters. And then you can do basically the same thing for the time interval. So if we want our change in time, delta t, we take our final time t2 and subtract our initial time t1, and we expect to get a positive value here because, as always, time moves in the forward direction. Let's make that minus sign clear. And so here we've got 2.1 seconds. All right, so you plug that in for delta t, plug your minus 7.6 centimeters in for delta x. You divide the two, you've got some centimeters divided by some seconds, so we expect our answer to be in centimeters per second, and you end up with minus 3.6 centimeters per second. And so that is our average velocity as requested. Notice the difference here between average velocity and average speed is that average speed would be the magnitude of this, so it would be positive 3.6 centimeters per second. But since we're looking for average velocity, we need to also know the direction. And here, moving in just one dimension, direction is indicated by a positive or negative sign. So it's that negative sign there that tells you the direction of your average velocity, which is what we want.